We are on 1.4, add and subtract polynomials. Well, in order to add and subtract them, we have to know what is a polynomial. And before we get to polynomials, let's start with monomials. You're going to have to pause this video as we go, write down some definitions. First one, monomial. Mono, of course, right there, means one. So we are talking about a single number, a single variable, or the product of those. So it could just be a number, could be 5. That's a monomial. Could just be a variable, x. That is a monomial. Or it can be the product of those. So maybe 5x. That is a monomial. The exponents that are on these have to be whole numbers. So we could have 3x squared. That would be a monomial. But something like 5x to the 1/2, nope, no good. That is not a monomial. Oops. Because that 1/2 is not a whole number. We also wouldn't want negative exponents. So 2x to the negative second, not a monomial. -2 is not a whole number, it's an integer. Okay, so then we have degree of a monomial. It is the sum of the exponents of the variables. And we remember that, I don't know why I keep right clicking there, that sum means addition. Okay, so we are adding up the exponents on any one variable, or any of the variables. So if you look here, this would be an invisible 1, so the degree of this monomial is 1. Same thing here, it would be 1. 3x squared, the exponent is 2. So none of these had any to add up, but maybe we had a monomial that said 5x squared y to the third. That's a monomial because it's the product meaning multiplication, of a number and one or more variables. We've got our whole number exponents, so we have to add the exponents on the variables. The degree of this would be 5. It's not 5 because of this 5, it's 5 because 2 plus 3 is 5. Okay? If you just have a single number, we have no variables, so therefore we can't have an exponent on the variable, so the degree of this would just be 0. The degree of this 5 would just be 0. So underneath, I'm just going to write down the degree of each one. This would be 5. My pen isn't working how I want it to. 5, 0, 1, 1, and 2. Okay, let me pause it and see if I can fix this pen. Okay, then we have polynomials. Mono means one, poly means many. So we're talking about a monomial or the sum of monomials. Each monomial is called a term. Here's an example of one. So in this example, you can see there are many monomials. Here's a monomial. Oh my gosh. Here's a monomial. Here's one. Here's another one. Here's another one. So if you take monomials and you start putting them together with addition or subtraction signs, that creates a polynomial. We call each of those underlying monomials a term. Okay, so once we take monomials, turn them into polynomials, then we have terms in those polynomials. The degree of a polynomial is the greatest degree of its term. So you want to look at each term separately and find the degree. So 5x, the degree is 1 because we have x to the first power. The degree of 7 would be 0 because it has no variables with it. The degree of 3x squared is 2, and the degree of 6x to the fourth is 4. So therefore, the greatest of those numbers is 4. The degree of this polynomial is 4. You can have more than one variable in a polynomial, but we will only work with ones generally that have one variable in the entire thing. And in that case, it's just the highest exponent on all of your terms. Okay. Another vocab term is just coefficient. You've heard that before. Remember what that is? It's the number in front of the variable. So 5 is a coefficient, 3 is a coefficient, and 6 is a coefficient. 7 all by itself, that's not a coefficient, it's just a constant. Okay, standard form. standard form is written so that exponents of a variable decrease from left to right. Okay, so you want to have the highest exponent coming first. So that means if I'm in standard form, I shouldn't have any other exponents higher than 2. Okay, so that is an example of standard form. And we know, of course, those ones, we don't actually have to write them. Okay, example, rewrite in standard form and answer the following. You need to write that first example in. I don't think it's in your notes. So again, just pause the video whenever you need to write stuff down if it's going too fast. Okay, standard form, the highest exponent is a 2, so I'm going to write the term with that down first. I always keep the sign in front with that. So plus 2x just is positive 2x squared. The next one would be the 3x, but I need it signed, so I write minus 3x. And then lastly, I have no variable, no exponent, so plus 4. The degree, if you look at each one individually, the highest exponent is a 2, so the degree is 2. How many terms are there? Well, we moved how many different things down into our answer? There was 2x squared, negative 3x, and 4, so 1, 2, and 3, 3 terms. Okay, you go ahead and try the second one, pause it here, and do the problem. Okay, check it out, see what you got. 3y to the 5th should come first, highest exponent of 5, then the exponent of 3, exponent of 1, and no exponent. There are 4 terms, 1, 2, 3, 4, and the highest exponent is a 5, so that is your degree. Okay, polynomial names. If a polynomial is only made up of one term, mono, of course, means one, so that would be a monomial. We've already talked about that. So something like x, or 5, or 5x squared, or 5x squared y. Those are all monomials. Binomials. You guys have ridden a bike. A bicycle has 2 wheels. A binomial has 2 terms. So we have something like 2x plus 5, or negative 3x squared minus 2. 2 terms. Terms are separated by plus and minus signs. Lastly, trinomials. Maybe you've ridden a tricycle when you were little. Those have 3 wheels. Trinomials have 3 terms. Again, I apologize, my pen's not working very nicely, so my writing's kind of crazy. Example there. 2x squared plus 5x minus 7. Maybe you have, oh, see, it's just crazy. Get rid of that. Let's try something. 3x to the 4th power plus 2x squared minus x. That's a trinomial. Okay, so some vocabulary there for you. Okay, and what the section really we want to dig into here is adding and subtracting these things. So if you look at this first problem, you have 2 different polynomials. This one is a polynomial and this is a polynomial. And I know that because they put parentheses around it. But other than telling you this was one polynomial and this was a second polynomial, by the way, they're both binomials because they each have 2 terms. Other than that, though, those parentheses aren't doing anything. So we could actually think of this problem as having no parentheses and just being 9x plus 7 plus 4x minus 10. And if we look at it like that, without the grouping, all we need to do is find like terms. Like terms have the same variables with the same exponents. 9x, 4x, those are like terms. We get 13x. 7 and negative 10, those are just normal numbers, constants. Those are like terms. Combine them and we get minus 3. Okay? Same thing on the bottom. The parentheses really don't matter. You don't have to rewrite it again. You can just kind of ignore the parentheses being there. And you would take 3w to the 3rd, find its like term. That's plus w to the 3rd. Remember, that's a 1w to the 3rd. So 3 plus 1 is 4. and the w to the third stays the same. Sometimes students want to change the exponents when they're adding. You don't do that. You've got 3 wheels. You want to add 1 wheel. You get 4 wheels. You don't change what those wheels are. Okay, I'm saying w to the third is equivalent to a wheel. It doesn't become something else like, I don't know, a buffalo. You'll still have a wheel. So your w to the third stays w to the third. Next one, you have negative 3w squared. Whoops. And that would be like terms with positive 5w squared. And so we get positive 2w squared. Last one in our first polynomial is plus 7. Plus 7 is like terms with minus 4. Missed my minus sign. And you get plus 3 there. Now, it's nice because I marked these off. That way I can very easily see I didn't ever do anything with this plus 2w. And that's because there was no just w term in my left polynomial, my first polynomial. So I'm just going to tack that on at the end. The only problem with that is it's not in standard form. Standard form wants your highest exponent first, your 3, and then keep decreasing. There's your 2. So the 2w to the first power should come before the 3. So make sure your answers, you want to put those in standard form. Okay. Subtracting polynomials, really similar, but just one more thing to think about. If you think about these, there's really ones outside of here. And I can go back to the last page. There's really a 1 right there, right? And there's really a 1 right here. And you could think of this as distributive property. But if you multiply by 1, does it change anything? No, you still have 9x plus 7. If you distribute a positive 1 here, you still have 4x minus 10. The difference is when you do that on a subtraction problem, your first polynomial is not going to change, but your second polynomial, you're not distributing positive 1, you're distributing negative 1. So you need to make sure you do this. So you have an extra little step on subtracting where you have to write without the parentheses. So I copied on my first polynomial, 12y plus 7, because distributing 1 doesn't change it. But back here, when I distribute the negative 1, it becomes negative 4y, and my negative or minus 5 becomes plus 5. So you really need to watch your signs whenever you're doing subtraction with polynomials. Then combine your like terms. 12y minus 4y. Those are your like terms. That gives you 8y. And then positive 7 plus 5 is positive 12. Okay, so it's not 7 minus 5. You've got to make sure you look at this negative sign or this minus sign and make them two double negative, minus and a negative, become a positive. Okay, down here, first polynomial, nothing happens to it. It stays the same. But we have to distribute the minus sign to everything in the second polynomial. So minus 5a squared, minus 2a, and plus 4. Combine your like terms, 3a squared minus 5a squared is negative 2a squared. Negative 2a, those do not cancel, they're both negative. So negative 2 minus 2 more, negative 4a. And then we've got positive 7 and positive 4 to make positive 11. Okay, 4 problems here. I'm going to do the first one with you. We see it's a subtraction problem, but there's also a number right here. It's not just a 1. So you need to take this negative 3 and you need to distribute it to the stuff in the back. The first one stays the same. Distribute that negative 3. Then we have negative 12x. Make sure you distribute it to the negative 10. Negative 3 times negative 10 is positive 30. Then look for your like terms. 5x and negative 12x is negative 7x. And 7 and 30 is 37. You try the last 3 and we'll come back and see how you did. Okay, check your answers. See if you got what I got. Do a little highlighting. First one, this is your answer. Second, oops. And then finally here. Notice my answers are in standard form. Sometimes you're missing a term. For example, my last problem goes from end of the fourth. There's no end of the third term, and then end of the second. That's okay. If they're missing one, no big deal. You just leave it out. No end of the first term, no big deal. Check them out. If you missed something, go back and see why you missed it. See if you forgot to distribute something or if you messed up maybe a negative sign. Watch those. And then go ahead and finish the rest of your packet.